So to outline the program, what we are going to be talking about, first we are going to outline the difference between raster and vector graphics, then something about color, and then we are going to focus mostly on raster images. So we are going through some differences between like graphics as it goes, like painted in the computer, I would say, or photos. We are going to have a look at compression and metadata. Then we will sum it up as a practical advice, like which file types or image types you should use for what. And then we're going to have some fun with perceiving and editing raster images as matrices, and going through some details about transforming the values, transforming the colors, transforming the size, which I think is like the most important thing to understand. And then we will have a look at Microsoft Office and how evil it is to your images. Yes, so the first topic you need to understand is to understand the difference between vector graphics and raster graphics. With vector graphics, or colloquially known as curves, the whole point is that the computer basically remembers all the graphical elements as lines or objects. So the computer knows that there is, let's say, a line that should go from point 1 to point 2 and how curved it should be and whatever. And it always draws the image points on your screen by going through this curve and just making the image point again and again every time it displays it. So with vector graphics, like the most simple element or object is a line, which is usually defined through anchor points, and you can see it as the objects on the line on the right. And anchor points can have several types. There can be like sharp objects where the line turns sharply, or there can be or the anchor points can be smooth, in which points you have basically through the guides you have control over the curvature, because you are defining like the tangent to the curve at the anchor point. But that's just unnecessary detail. What is important to understand is that vectors are scalable however you want, because the computer knows that there is a line going from here to there. It can draw it in any amount of details that you want it to do. So vector images don't have resolution as like commonly let's say commonly taken, and you can zoom them basically indefinitely. And what is another important point is that objects remain separate in vector graphics. So if you make, let's say, a circle and then you draw a line through that circle, you can still select the circle under the line and select the line on top of it. They remain separate, and you can then edit them as you need it. Of course, it's not only like curves and lines. Vector graphics can also contain areas, let's say circles, rectangles, whatever, filled areas, and editable text. And also, which may be a little confusing, it is possible to import like some raster pieces as like defined let's say patches of raster image inside the vectors, but let's not go into that yet. The upside of vector graphics is that you are not, of course, limited with any determined resolution, and you can edit them how you want. You basically can always select the individual components and go back. Common formats of vector graphics are SVG, or scalable vector graphics, WNMF, Windows Metafile, EMF, Enhanced Metafile, EPS, Encapsulated PostScript, then Adobe Illustrator documents, and PDF. The point with, or the slight trouble with these vector formats is that almost all of them can also contain these small pieces of raster images. For some of them it is quite common, let's say for PDF. For some of them it's really rare, but just beware that this can happen. And common programs for editing vector graphics are Adobe Illustrator, Inkscape, LibreOffice Draw, and Microsoft Office. So this is maybe like the most common, let's say, impression or common place you can see vector graphics, or at least the basic principles, is that when in Microsoft Office you draw a rectangle or a line, or you're editing some let's say chart or something in Microsoft Office. This is vector graphics, even though Microsoft Office is not, let's say, graphical software or dedicated graphical software, but you know the stuff when you can like group objects together, but then expand them back into separate objects and so on. So yeah, this is the concept of vector graphics. On the other hand, we have raster graphics or bitmaps. Here, the idea is completely different, and the idea is that you have a grid of image points, pixels. Each pixel have a certain color or level of darkness, etc., and together they constitute the image. The main thing to remember that the resolution is always set and limited. So you can zoom, but if you zoom in, it will not get prettier, it will just get blockier. So that this is the consequence of the limited resolution. And also because you need to store each, let's say, pixel as some amount of data, the file size, generally speaking, increases with the size, with the resolution of the image. Of course, there may be some exceptions, but generally speaking, this is the case. And another point is that in raster graphics, there are no objects. There is just the grid of image points. So when you are drawing, let's say, a circle in Microsoft Paint or some raster editor, the moment you finish the circle and you are done, it gets basically projected or burned into the pixels of the image, and you can no longer edit it. You can, of course, undo and so on, move in the history of editing, but it is no longer an object that can be selected as on its own. And so yeah, the point about raster graphics is that it is, let's say, less editable because you cannot disintegrate it into these graphical objects anymore. But the advantage is that usually this of course quite difficult, but usually it is more universally compatible because you are not trying to, let's say, render a circle in this position. You just have let's say, hard definition of the points that you need to draw. Of course, inherently, rasters are the format for photos because this is the way our eyes work. This is the way the sensor in the camera works. So of course, the output in this is again raster graphics. And the main point I will get back to further in the presentation, but to remember that unlike vector graphics that can be scaled however you like, raster graphics cannot be enlarged without losing quality, or without, like, well, basically the quality can stay the same, but you can never, if the information is already gone or is not present because the picture is too small, you cannot just click some magical enhance button and to restore the information once it is reduced, or when it's too small, then you cannot enlarge it. Of course, I'm sure somebody can point to me, let's say maybe some neural networks that can try to be maybe trained to try to guess this detail and edit artificially, but that's, I would say, beyond the um, common scope of image editing. Common raster formats are BMP, Windows Bitmap, PNG, Portable Network Graphics, the GIF or GIF. I will call it GIF because I'm just used to calling it a GIF, which stands for Graphics Interchange Format. And then we have JPEGs, which are mainly just the default format for photos, and we have TIFFs. And common programs for raster graphics are MS Paint, which is, like, I think what we are all started with. Then I would say the most famous, Adobe Photoshop, and some free alternatives to Photoshop can be GIMP or the PaintNet that we are going to talk about more. So this is for the introduction of the difference between rasters and vectors. And now for some practice, we can go to the folder with our practice materials and have a look in the first folder with the smiley face. Here I have the two files that are in the practice one smiley face folder. And the small trouble here is that I cannot know what sort of software you are running on your computers, and of course, what are your default associations for programs opening these files. So maybe just for a basic demonstration, we can use Microsoft Paint, which we should all have. If we can find it, yeah, here we have it called malování in Czech, and we can use it to open the PNG file. And there you can see basically when the difference between rasters and vectors just is clearly visible is when you zoom in. So when you hold your control key and use the mouse wheel to zoom, which by the way is super convenient thing to know, that in basically all programs you can zoom with holding control and using the mouse wheel to zoom in and out, except for Adobe everything when it's the Alt key, but generally everywhere in Windows it is with the control key. And you can see that if I zoom in on the eye of the smiley face, it is another smiley face, but it's sort of pixelated. And in the eye of this second smiley face, there is another smiley face, which is just barely visible because it's very seriously pixelated. So this is the limited resolution. So even though it looks fine, it looks fine from a distance, you can see that you cannot enlarge it indefinitely. There is some limitation. On the other hand, if we have a look at the SVG smiley face, by the way, for opening SVG files, I think that to use your internet browser is let's say, the easiest way how to do it. So I will just use my Google Chrome here, and you can see that from the first look it looks the same. But again, if I start zooming in and trying to keep the center on the eye, well, yeah, I've hit the limit of zoom, which can be used here. But you can see that the resolution is still very nice. It's not pixelating because it just knows that it should be a circle, and it always calculates the shape of the circle depending on how close you want to view it. So the unlimited resolution and unlimited zooming of vector images is clear. In the meantime, I had a look in the chat, and some was commenting that Office objects are basically zip files. Yeah, it's yeah. This is true. Basically, going from dots to dots.x format. I think they basically made it an archive, and you can sort of disassemble. You can sort of disassemble Office objects this way, or not Office objects, but Office documents as such. Okay, so of course we have these two types of graphics, vectors and rasters, and sometimes you have one and need the other. So what are the possibilities to convert them? Well, converting from vector to raster, it's, I would say, quite easy, because basically the computer needs to do it anytime it's showing it on the screen anyway. So usually you have the possibility to just export from the viewer wherever you are viewing the vector graphics. You can also use virtual printing. If you, for example, many virtual PDF printers have the possibility not to save only to PDF, but also to PNG, JPEG, and so on. So virtual printing is another way how to get somewhat controlled export of rasters from vectors. And in a pinch and in a hurry, when you just need some quick and dirty raster from a vector, well, if it's already drawn on your screen and you are not concerned with any particular quality, you can just take a screenshot, then crop it, and voila, you have a raster export of your image. When you are exporting and when you have some control over it, of course, you should always consider the intended purpose of the raster that you are going to be using it for. So if you and adjust it accordingly, when you can, for example, if you are setting the resolution of the export, remember that once it's exported, you are limited by this resolution, and it's not going to be any higher unless you re-export it. So just be aware of that, and it is always better to go with higher resolution and higher quality, because you can always reduce it in the end, even in the raster, but you can never inflate the raster again. On the other hand, converting the other way, if you have a raster, converting to vector is, let's say, quite difficult. And I'm writing here approximate. So, of course, when you have you have a picture and you are trying to, which has, the picture usually has some noise in it and some, let's say, small details, and you are trying to replace the areas, like, let's say, find monotonous areas in the image and replace it with solid shapes, which is always going to produce, let's say, not very precise outline. It can be a hassle. Well, for photos, it's not really easy. Usually, well, of course, if the silhouette, let's say, or the shape in the photo is really clear, then it's possible. But generally speaking, it is, of course, easier with images with big monotonous areas and good contrast. And another, let's say, significant limitation is that I'm not really aware of any good vectorization software that would be for free or just available in Microsoft Office or in Windows. Maybe there are some online tools for that. It is always a good idea to look online, because for some graphical tasks there are just quite easy online tools. But yeah, to find a suitable software to vectorize your rasters can be, let's say, quite difficult. I have some examples here. And even though this is a photo, the original on the left, you can see that the outline is really clear. There is a big contrast between between the stuff we want to, let's say, outline as the vector object. And on the right, you see the result of vectorization I did in Adobe Illustrator, and you see that the shape is basically perfect. On the uh, other here, this example, although similar in its, let's say, spirit and motivational potential, the technical details of the photo are quite different because of the lights and shadows that are, let's say, breaking up the silhouette. If we do just a binary vectorization, of course, our brains can make out the overall the overall shape of the girl there, but you see that it's not clear, the outline. So there are basically some gaps where the lights were, and so on. The other approach we may use is not to vectorize it only as binary objects, but to vectorize it in some limited, let's say, steps of color. Again, it is someone may like the visual aesthetic of the bottom example of the colored vectorization, but again, the difference between the original and the vectorized one is really clear, and you cannot see that, or you see that it's not one-to-one copy of the shape and whatever. It's more like a stylized thing than the original shape transferred accurately to vectors. All right, so this concludes, I would say, the first quite important bit here.